So let's have a go at this one. So what you're going to do here is, rather than having it y equals something, I mean, you could try and rearrange this: y squared 25 minus x squared, and then try and do the, okay, try and do that. But when I do that, I'm having to do it twice, aren't I? With this positive and the negative one. So that's why we don't do it, okay? So that's what we don't do. What we do instead is differentiate it in sort of parts. So what's the derivative of x squared with respect to x? 2x. What's the derivative of y squared with respect to x? That's that one we just had. So that was the 2y dy by dx. Okay? That's your composite rule. Remember, y squared is like that. What you're doing with that, the chain rule, the product rule, whatever, that goes down the front, and you multiply that by the derivative of that, which is y dash. Okay? So that's the hard part. What's the derivative of 25? 0. Okay? So that there is your implicit differentiation. Does that look okay so far? Okay, we'll get much harder, but now when we want here, we want dy by dx equals something else, don't we? So what I'm going to do now is go dy by dx with its 2y is equal to negative 2x. Can you see what I've done? Take the positive 2x on the other side. Divide this by 2y, and what do I get? Dy by dx is just negative 2x over 2y, which hopefully you guys can understand as being just negative x over y. Okay. So at the point of 3, negative 4, what's the gradient? At 3, negative 4, the gradient is negative 3 over negative 4, which is just 3/4. Substitute the x and the y. Can you see that? So what's the equation for the tangent then? Just a little quick aside. Remember the tangent? How do I write the tangent one? Y minus y1 is the gradient into x minus x1. Remember that? So y minus y1 equals the gradient into x minus x1. Now, what do I do with these sort of equations? You guys remember from last time? Multiply the whole thing by 4 to get rid of that fraction. Okay, so 4y plus 16 equals 3x minus 3. Expand that out, that's 3x minus 9. Add the 9, that's going to be 4y. Do it over here because I've run out of room. So 4y minus 3x plus 25 equals 0. There is the equation of my tangent to that circle at that coordinate. Okay? Happy with that? Does that seem hard?
Can you guess that like on these ones?
Yep. Okay, so as I just said, these are the ones where it gets a little bit trickier. You can automatically see that this is not done in just simple parts. X squared plus y squared is 25. Okay, we've got a relationship between x and y that is a product, eh? So when we're differentiating that, we have to use the product rule. Okay, so product rule again. Write down the first, differentiate the second, plus write down the second, differentiate the first. Is that right?
Yeah.
So that part there is now going to be, sorry, just check that again. That's going to be 2x squared. What's the derivative of y? dy by dx. Now, write down the second. Derive the first one. That's going to be times 4x. You happy with that?
Yeah.
Can everyone see that? Okay, so the second part, now it's this part here. Write down the first part times differentiate y squared. Wowzers. Settle. Go back here. Times 2y dy by dx. Then you're going to write down the second one, y squared, and differentiate the first. Don't forget to differentiate the constant 16 and make sure you make that equal 0. Now that's automatically a little bit complicated, eh? Can I make it a bit easier? Just like collecting and making it a bit tidier. So it's just 2x squared dy by dx plus 4xy plus 6xy dy over dx plus 3y squared is 0. Happy with that? Have I done something wrong? No? What's that, sorry?
Where are all the additions coming from?
The product rule. So that part there is the product rule for that. This part here should be the product rule for that one there, differentiating that and that. The product rule.
Yeah, because it's two different ones. Oh, no, right, no, yeah.
Yep, plus in the middle. Okay. So, where do we go now? What do we do now? We want to make dy by dx the subject of my formula, right? So I'll leave my dy by dx is on this side, or the terms have it on the left-hand side, and make the other ones on the right. So 2x squared dy by dx plus 6xy dy by dx equals negative 4xy minus 3y squared. Can you see what I've done there?
Yeah.
I've just moved that one and that one to the other side of my equal sign. Now I've got this constant term, I've got this factor here of dy by dx. So I take that dy by dx out, that constant factor, 2x squared plus 6xy equals negative 4xy minus 3y squared. You follow me there?
Yeah.
Now what do I do?
Divide.
Divide by that bracket, eh? So, dy by dx equals negative 4xy minus 3y squared all over 2x squared plus 6xy. And that's going to be my gradient. Now, I'm not going to stand here and say that's easy, but
How many times have you seen that?
probably quite a few. Okay, that's complicated. It looks complicated because there's so many x's and y's and whatever. Right? But in reality, if that was written as z's and x's, it wouldn't be as bad. The maths you're doing there, a little bit of factorising, a little bit of expanding, a little bit of finding the form, making x a subject of the formula, it's not too bad. So now we're trying to find the normal of at the point 1, 2. Now, how would I find the normal at the point 1, 2? Yeah, no, I've actually got 15 minutes now.
Yeah.
But yeah, I made it look stuff.
Inverse of the 10.
Inverse of the...
Find the gradient, then inverse.
Okay, so it was at 1, 2, was it not?
Yeah.
Okay, so dy by dx at 1, 2. That's negative 4 times 1 times 2, that's negative 8.
Yeah. Okay, this next one.
Y squared 4 times 3, that's That's 12. That's minus 12. Is that right? I tried to write down negative, but then okay, fine. I'll just make it negative. Have you that?
Yeah.
Okay. That's going to be 2. That's going to be 6 times 1. That's 12. Is that right? So that's going to be negative 20 over 14, which is negative 10 over 7.
Nice, man.
Now, if that's dy by dx, what's the equation? What's the gradient of the normal?
Inverse negative.
Normal, therefore, gradient is 7 over 10. Okay, and then you put it back into that y minus y1 equals the gradient into x minus x1 times everything by 10 because you don't like the fraction. Okay, and then collect everything on the one side. That's minus 7, put on the other side be a plus 7. There's my answer. Okay. Now, hopefully that stuff there makes sense because we've done a couple of those sort of questions. Find the equation of the normal. Okay, it's going to be included in one of these other questions. But does that make sense?
Yep.
Is it hard?
Yep.
But it's do it in processes, and it will become easier for you. Yes.